Okay, welcome back students. So in the previous class we shall finish the topic De Morgan's theorem. Okay, so in this class we study basic duality principle of Boolean algebra. We already studied the principle actually, but we done some problem, and that problem is very easy but very important. You see, first one is give the dual of the following. Give the dual of the following result in Boolean algebra. In Boolean algebra. And that is 0 for each x. See, what is the questions coming? Give the dual of the following result in Boolean algebra. X dot x complement means x bar or x complement, okay, for each x. So what is the principle? Principle means, you see, if you remember that there is three rule. First rule is changing or sign to n sign. Okay. Second one is changing n sign to or sign. First rule changing or sign means plus 2 into, and second one is into to plus. And third rule is very easy, means 1 to 0 and 0 to 1 inverter. Okay. By using that formula we solve it, and solution is using duality principle. Using duality principle, dual of this. How? You see, this n sign is converted to or sign, and this 0 is converted to 1, and this is the x plus x bar is equal 1, and you have to write under bracket as a note. See, by changing to or sign, and vice versa means opposite, or a multiply to plus or plus to multiply, and vice versa, and by replacing ones by zeros and vice versa. Okay, this is under bracket. See, using duality principle, dual of x dot x complement is equal 0 is x plus x complement is equal 1, means n sign is converted to or sign and 0 is replaced by 1. Okay. Second one is, second question is, you see, give the dual of x plus 0 is equal x for each x. Okay, this is the expression x plus 0 is equal to x for each x. You have to be find the what dual of this expression. Okay, means this is the expression x plus 0 is equal to x. You see, OR sign is converted to n sign and 0 is converted to 1. Using duality principle, okay, dual of x will be or is same thing, x dot 1 is equal x for each x. Understood? This is and last question is, you see, last question. State the principle of duality. State the principle of duality in Boolean algebra. In Boolean algebra and give the dual of the Boolean expression and give the dual of the Boolean expression. Okay, and what is the expression? X plus y into x bar plus z bar into y plus z. You see, what is the questions? This is last questions of this topic. Dual principle. State the principle of duality in Boolean algebra and give the dual of the Boolean expression. Means x plus y into x bar plus z bar into y plus z. Means we need to be change the n sign to or to n, and 0 by 1, but there is no 0 or 1 in this expression. That's why we just using first two rule. Okay, so first part of the question is this: state the principle of duality in Boolean algebra. We need to give the principle of duality in first expression, and second expression is give the dual of the Boolean expression. Okay, the first one is, you see, principle of duality states that principle of duality states that from every Boolean relation from every Boolean relation, another Boolean relation can be derived by number one, changing its or sign to and sign. Changing its and sign to or sign. And replacing its 1 by 0 and replacing its 1 by 0 and 0 by 1. See, Minterm duality states that from every Boolean relation, another Boolean relation can be derived by changing its or sign to and sign, changing its and sign to or sign, and replacing its 1 by 0 and 0 by 1. Okay? Means, I already told you, means plus 2 into and into 2 plus, and replacing 0 by 1 and 1 by 0. This is the main rule. And now we have to be answer the second part, give the dual of the Boolean expression, this expression. Okay? You just continue writing. I erase this, there is no enough space here, that's why. Okay. Second is the new derived. You just continue. The new derived relation. The new derived relation is known as the dual of the original relation. The new derived relation is known as the dual of the original relation. Dual of this expression x plus y into x bar plus z bar into y plus z will be what? X dot y, this n sign is, or sign is converted to n sign. There is nothing means n converted to or. And this is equal, you can directly write x y plus x bar z bar plus y z. Okay. Understood? Means xy plus x bar z bar plus yz. This is the dual principle. So duality principle is over. Next topic is very important. Derivation of Boolean algebra or derivation of Boolean expression. So first of all, for derivation of Boolean expression, you need to be know the very important thing, mean term and max term. And the questions from that topic is also come, maybe come or come. Mean term and max term. You see, derivation of Boolean expression. So, in derivation of Boolean expression, you see, we need to derive some Boolean expression, okay, like in terms of variable, but using for solve that evaluated expression, we need to be know the some definition, and definition of what? Definition of mean term and max term. Then how mean term is defined, how max term is defined, you need to be know that first. Okay, so first one is concept is literal, means any variable or any complement of the variable, means any variable or complement of any variable is called literals. You see, you write down Boolean expressions which consist of a single variable or its complement, or I am say already, or its complement. Example, for example, x or y or z bar means complement are known as literals. Means Boolean expressions which consist of a single variable or its complement, for example x or y or z bar, are known as what? Literals. Okay. So, honest copying. So, I already told you before starting the evaluate the Boolean expression, we need to know the term is mean term and max term. We need to study first of all is mean term and max term, and how mean term and max term is find. Okay. Let's see. First one is mean term. Okay, so write the definition. A mean term, the detailed note will be already provided in the book. You just read by yourself. Okay, I don't give you the note. Just I give the concept. Okay, how mean term find. So our definition is a mean term is a product of mean term is a product of all the literals A minterm is a product of all the literals with or without the bar. Literals means with or without the bar of variable, okay, within the logic system. Means product of all the literals with or without the bar within the logic system. Within the logic system. Okay, this is the main definition. Now you see some rule, or you can say step to find minterm. Generally minterm is product of all the literal and maxterm is sum of all the literal, or you can say product of sum or sum of product. You just got it in the some letter word canonical expression, sum SOP or POS. Okay, so a minterm is a product of all the literals with or without the bar within the logic system. Okay, so steps involved in minterm expression, in minterm expansion of expression, in minterm expansion of expression, you see, number one step is first convert the given expression in sum of product from. I already told you, first convert the given expression in sum of products from. Sum of products from. This is the first step. First convert given expression is sum of product. Mean SOP. This is the concept. See, product of all the literals. Literals means with or without the bar. Means complement. Same thing. Second step is in each term if any variable is missing, for example, in each term if any variable is missing. Example, in the following example, y is missing in first term and x is missing in second term, x is missing in second term, multiply that term with missing term. You see, this is the concept. Multiply that term with multiply that term with missing term or complement of missing term. Missing term or complement of missing term factor, that is, for example, if I just write down and I just teach you, you just wait, y is missing, multiply with y plus y bar. See, but the second step, in each term, if any variable is missing, for example, in the following example, y is missing, okay, in first term and x is missing in second term, multiply with that term with missing term plus missing term complement. Example, y is missing, multiply y plus y bar. Means concept is, suppose there is an expression, okay, x plus y, okay, take it, in that x, y is missing, and in this y second term x is missing, then what happen, x is equal y plus y bar and y is equal multiply with x bar, and then you have solved and we find the minterm. We just done some problem, then you easily understood, okay, don't worry. Just I show you, suppose again I am show you x plus y, okay, in first term y is missing, in second term x is missing, then what we multiply with term, missing term plus missing term complement, means x is multiplied with y plus y complement, y multiplied with x plus x complement, right, and then we can solve. Okay, this is the basic two rule. Last two rule is left. You just write down serially. Third rule is expand the expression and fourth one is remove all duplicate terms and we will have minterm form of an expression. Minterm form of an expression. Means third one is expand the expression and fourth one is remove all duplicate term. We just done the problem and we understood. Next is, and we will have minterm form of an expression. Okay. So, okay then, this is enough for this session. In next class, we done some problem of that minterm. Okay. So, if you any doubt, you can ask me. Thank you.